Okay, so here I have my favorite class, 651.
3-2.
So here we have 632, and I'm going to be showing you exactly how we do our endothermic reaction lab. You can see we have 3 test tubes, test tube rack. We have an empty paper cup, nothing under the paper cup. We have 1 cup labeled A, which has citric acid, 1 labeled B, which has baking soda. We have some water, and we have a thermometer. So what we're going to be doing is we're going to be using as our dependent variable what?
Temperature.
Temperature is going to be a dependent variable. It's next endothermic lab, so we want to see how low the temperature will go. So what the students are doing is they are either combining a certain amount of powdered citric acid and or a certain amount of powdered baking soda, or they're making it into a solution, or one or the other. It doesn't really matter, whatever they came up with. So let's take a look, and as I told them, and I'll tell you again, that these are micro labs, so the materials we use are very limited. We don't need a lot. So just for example, let's take a look, and let's get some water into this one right here. You know what, let's do the powder first. So this is a good way to do it. So we would take, as I told the students, to hold the test tube and the cup in the same hand. And so this is our citric acid. So say they're going to use the same amount of, equal amounts of citric acid and baking soda, but they're going to vary the amount of water that they're going to add to make it a solution. So say they're going to use 1, 2, 3, 4, 5, 6. I'm counting for the benefit of the students who have a difficult time counting. 6, 7, 8. Good. See, look how they're learning. 9. See, I can hear them in the background. And 10. Okay, so now that's our citric acid. Now we're going to put baking soda in here. And so 1, 2, 3, 4, 5. What comes after 5?
7.
See, they're so good. 7, 8, 9, right, 13, right. Okay, so now we have a combination of both citric acid and baking soda in here. So what they would do is they would have each one of these 3 test tubes filled up with equal powders. And this is always a big problem for them at the beginning of class. I always say, why don't you just make it as easy as possible? So they're unsure as to whether they should be, what they should be combining here or how they should be combining it. All they need to do with this is they just need to vary the amount of water they're going to put in. So, in fact, I'm going to give them an extra test tube. So let's take this test tube and say we put in, for the first one, we're going to put in 2 milliliters of water. So we take, let's put them in here. So we take 1 and 2. Okay. So now what we need to do is we need to know what our starting temperature is. And again, when you're doing this, there's going to be some type of procedural non-specificity. So we can just use the ambient temperature, the room temperature, starting at, in Celsius, we are 22 degrees Celsius. So what we're going to do is we're going to take this and we're going to put this in here, and as soon as we put it in, we saw the other day the reaction goes very quickly. So we're going to put this in, and we don't have to time this. I took away the stopwatch. We don't have to time this. But what we do have to do is we have to have some volunteer, let's just myself, come down here, and as soon as I put this in, we're going to come over here and we're going to put the thermometer in. I can actually pick this up. See what our temperature is. And the temperature's going down. You can see it's still bubbling a little bit. Getting a little bit colder. It won't run for that long because it's micro lab. Our substances are not that great, but it is going down. So this went down to about, and I would say it's about done, since the bubbling has ceased almost. We're down to about 20 degrees Celsius. So what we would do is we would take this out and we would wipe this off, and So our temperature change would be 2 degrees Celsius. So we'd mark it down on a piece of paper, test tube A, and that would be 2 milliliters of water. Does anybody have any questions? Yeah, gangsta boy with the hood on. Yeah. So you should have the hoods off in class. That's a good idea. You should have your ID tags on. Yes, question?
Couldn't you take the temperature of the citric acid solution and not the room temperature?
Well, it's basically the same.
Well, we need to know before and after. We need to know what happens after.
So you
We could have taken this and put this into the water and gotten a neutral temperature from the water as well. Any other questions? Yes?
Can we first put in the thermometer and then put in the
No, because it's a bit of a pain to do that. So as long as you know what your starting temperature is, once you put it in, it's going to go down and it'll run its course. Any other questions? Yes?
Are we gonna do labs more like these in the future?
Let's take it one day at a time. Okay, and that's about it. Parents, if you have any questions, you can always, I doubt if you'll have any questions. It's a pretty straightforward lab. And thank you, parents. Have a good day.